Hello, you're welcome. Let's solve this equation here. K dot K dot K plus K equals 30. So what's the value of K? So now we are going to have, K times K is going to give us K squared, then dot K plus K equals 30. Now here, K squared times K, we're going to have K to the power of 3, okay, plus K. Now this 30 here, let us take it to the left hand side. We're going to have 27 minus what? Okay, let me take it first. So we have 30 equals 0. So here we have K to the power of 3 plus K, and we can rewrite this 30 as minus 27 minus 3 equals 0. Right, so from here we have K to the power of 3 plus K. I can also rewrite this 27 as 3 to the power of 3 minus what? Minus 3 equals 0. Now, before we move on, so since we are having the highest power of K, which is the variable you are looking for, to be 3, so it means that we are going to be having the possible values of what? Of K, and they are going to be what? They are going to be 3. So therefore, we are going to solve for all the possible value, be it real or complex number. So let's see. So now from here we have K to the power of 3. We can combine these together, those that are having the same powers, minus 3 to the power of 3 plus K, then minus 3 equals 0. So now from here, now how are we going to do here? We have K to the power of 3 minus 3 raised to the power of 3. So there's something we can do here. We call something difference of two cubes. So when you have a to the power of 3 minus b to the power of 3. So this will give us a, take the negative, minus, then take the b, into bracket. Now square this one, which is a, then plus 2 times, plus multiply this and this together. We're going to have a, b, then plus square this, we have b squared. So this is what difference of two cubes will give you. So we are going to use this in here. So therefore, this is now going to be K minus 3, okay, using this, K squared, then multiply this and this together, plus 3K, then square this, we have plus 9. Okay, but don't forget that we have K plus 3 here. We have K minus 3 rather equals 0. So now from there, K minus 3 is here. K minus 3 is here. We can factorize it out. We have K minus 3, okay, into bracket K squared. Because if you divide K minus 3 by K, if you divide this K, this by this, we're going to have K squared plus 3K plus 9, right? Then K minus 3 divided by K minus 3 here, we're going to be having 1, then equals 0. So here we have K minus 3, then K squared plus 3K, 9 plus 1, we're going to have 10, then equals 0. So therefore, we have this 0 form equation. It is either K minus 3 equals 0, or we said K squared minus plus 3K plus 10 equals 0, right? So now, from here, we have K to be equals 3 if we transpose this to this side. So that is K1. So we have K1 to be equals 3. Now here, we cannot use factorization here, but let's check whether this is going to be complex number. Okay, so now let us check whether this will be complex, and if it is complex, then we can move on and solve for it using quadratic formula. Okay, or better say we can use quadratic formula from here. So we have to know the discriminant. No discriminant is b squared minus 4ac. So the b is what? This is the b here. The a, this is the a, which is the constant coefficient. B is 3 squared minus 4. A is the leading coefficient there, which is 1. Then c is what? C is 10. So we're going to have this, which is discriminant, to be 9 minus 4 times 10. That is what? 40. So you can see that our discriminant is going to be minus 31. So now, since we have the discriminant to be minus 21, that is the solution we are going to have for the rest of the root, they are going to be what? They are going to be complex. So, and we need to find it, because not the condition is not given to solve for real or to solve for complex. So therefore we need to solve for all the possible solutions. So we move on from there. Now, going by what we have the discriminant to be minus 31. So therefore we're going to have k to be minus b plus or minus square root of the discriminant, then divided by what? Divided by 2. Okay, so we have k equals then minus b, according to what we have before, minus b, the b is what? Is 3. We have minus 3 plus or minus, then the square root of the discriminant we got is minus 31. We have minus 31 all over 2. So this is going to be k equals minus 3 plus or minus, okay, then here we can split this as root 31 multiplied by root minus 1. So that when you multiply this and this together, it will give us this back, divided by 2. So k is going to be minus 3 plus or minus. So this root of minus 1 is same thing as I, then square root of 31 all over 2. So the next thing we're going to do is that we're going to have k2 to be minus 3 plus I root 31 all over 2. Then we have k3 to be minus 3 minus I root 31 all over 2. Then bringing the one we got before, k1, to be what? To be 3. So you see, we have this, and this. We are 1, 2, 3. So those are the possible values of what? Of k. Now let's check for just this, okay, because of time, or if I'm time factor. So check for when k equals 3, which is the real. Okay, so from the question given up there, we have k dot k dot k plus k equals 30. So if I put 3 here, 3 dot 3 dot 3 plus 3, is this one going to give us 30? Is this going to give us 30? Let's check. 3 dot 3 dot 3, that is 3 times 3 times 3, we're going to have 27. So this is 27 plus 3, okay, equals 30. Then 27 plus 3 will give us what? Will give us 30. So we have 30 equals what? Equals 30, right? So therefore, that's the end of the class. If you have not subscribed to our YouTube channel, consider subscribing today. Hit on the bell icon so that you'll be notified anytime we upload a new content.